My name is Noam Buckman, and I'm a recent PhD graduate here at MIT, and I studied in the Department of Mechanical Engineering. I was advised by Daniela Roos here in CSAIL and Professor Sartaj Karman in LIDS, and I'll be talking about the research I conducted during my PhD. And at a high level, I was looking into how we can incorporate into our autonomy models of how other humans act, and using an awareness of the humans on the road in coming up with our own autonomy, our own decisions. And so what I'll talk to you today about is some projects related to modeling the actual reward or cost that is internally going on for humans, where we're semi-cooperative, we think about other people when we make our decisions, and also work on thinking about what do the other human drivers or humans in our robotic environment, what do they even think about us, and what are they aware of? So thinking about things like blind spots for human drivers, how do we as a robot navigating around humans, how do we think about those blind spots or limited perception, and also things like failure. So if we have another human on the road that maybe is not a very good driver, doesn't really understand the rules of the road, how do we incorporate that into our planning? So I guess the first thing I worked on was how can we use concepts from social psychology about different cooperation levels of how humans act into how an autonomous vehicle does planning on, let's say, a highway. So for example, looking at an ambulance that might be autonomous and want to interact with multiple agents at the same time, and thinking about both how that autonomous ambulance makes decisions, but then also, for example, how the overall traffic on your road gets impacted by different personalities. One of the takeaways is that if you take existing approaches, either very competitive, individualistic approaches of how humans behave, or you do use kind of simplified models of how humans act, you would typically get scenarios where there's very little cooperation on the road. And we kind of know intuitively that when drivers do drive on the road, there are people that are willing to slow down for an ambulance or move out of the way for another vehicle. So what we found that emerged out of this was that if we modeled this kind of cooperation, we could capture this in our autonomy stack. So our autonomous agent could understand that there's a cooperative person and actually overtake them or work together to go faster through on the road. So what we observed was that there is a fairly direct relationship between how cooperative the humans are, their personality, and the performance on the road. I've done a lot of work on thinking about the underlying reward, or what are humans trying to optimize for. But there's an entirely other dimension, which is what are the other humans on the road even thinking about me? What are they aware of? So for example, when you drive on the road, you might find yourself in the blind spot of another vehicle, another human driver. They may not even know you exist. And it doesn't even matter if they're pro-social or helpful or cooperative. If they don't know you exist, they might even crash into you. So one of the areas I worked on was what I call visibility-aware trajectory optimization. And so the idea is, how do we come up with trajectories for our autonomous vehicle that can proactively think about something like blind spots? So what we did in that project is we modeled the underlying perception and estimation that a human driver would be doing. So instead of just saying, I don't want to be in a blind spot, or I want to avoid the other vehicles, thinking about actually how do we position ourselves on the road in such a way that the other vehicles can have a good estimate of where I am in the world. So that was one example where we're thinking about how the other vehicles are, and the other agents on the road are thinking and estimating our own position. Another one, which was taking a more data-based approach. So in the previous project, was talking about modeling how the other agents are thinking and estimating where the autonomous vehicle is located. And another approach would be to take a data-based approach. So actually training a neural network to be able to detect when there's something wrong going on with other cars. The idea, especially when we think about an intelligent intersection manager, is that ideally you'd be able to get this information or this signal of a failure a little bit before the cars even enter the intersection. So if you identify these failures a millisecond before a collision happens, not very helpful. But with an intersection manager that might be able to observe outside of the actual intersection square itself, hopefully we can actually identify the failure a couple seconds before the vehicles actually entered the actual intersection square. So what we did is, if our traffic lights identified a failure, so let's say there's a reckless driver who just seems to not be driving properly, maybe they're going to run a red light, the traffic lights actually will give red lights and signals to the other vehicles in the system saying, hey, if you're at the intersection right now, you should probably wait for this other car to go. So it's a fairly conservative warning system in the sense that it's telling everyone to stop and wait for this other car to go forward. But I think it's a good example of kind of how you can create a safety system. And in future, we might think about, if there are other autonomous cars, can they do other things besides just stopping? Like maybe if you have a car that's already in the intersection, they can speed up and try and get out a little bit faster. Yeah, so next steps, I'm looking towards seeing how I can utilize the skills and knowledge I've gotten through my PhD into industry. So whether that's working on autonomous vehicles, trying to develop algorithms for self-driving cars, or more generally speaking, different types of robots, whether that's in the home or delivering goods for you. And then I'm also excited to seeing about ways that I can also, just zooming out, how can I help bring more autonomy to the world, whether that's interfacing with government or coming up with ways that we can actually make sure we have safe and efficient autonomy out on the roads.